Okay, so we're working on problem number 8, and the first thing I like to do when I'm working on this type of problem is start with a force body diagram. I've got a negative frictional force here, which is negative kV. I've got an mg here, and I've got a normal force, which is also mg. There's only one force acting in the x direction, and so when I do my sum of the forces in the x, I end up with force of friction is equal to ma, and that's just equal to negative kV. So when you're solving for acceleration here, all you have to do is isolate the a in this equation. Now, when we are working with trying to find velocity as a function of time in part B, I'm going to take this equation again, but instead of a, I'm going to plug in dv dt, and that'll give me a function with respect to time. So I end up with negative kv equals m times dv dt. I want all my v's together, so this v and this dv are going to go to the right, and then everything else is going to go to the left. So I'm going to take negative k divided by m dt equals dv over v. And then I'm going to integrate. This negative km is just a constant, so I'm going to leave that on the outside, and I'm going to go from 0 to t time. And this one, I'm going to go from starting velocity of v naught to v. From there, I can do my integration, negative k over m, and then this one is t. Here we've got dv over v, which hopefully you've memorized is ln. That doesn't look like an n, but it's ln v from v to v naught. And then from there, we have to do the subtraction of our limits. So negative k over m is equal to t minus 0, which is just t. And then ln v minus ln v naught, which is just ln v over v naught. And this is negative kmt. Now from here, I want to get rid of the ln, so I'm going to take e to both sides, and I get e to the negative kt over m equals v over v naught, and then v is equal to v naught e to the negative kt over m. This would be my answer to part B. Now we also have to graph it, and when you think about the function, we start off with time 0. If time equals 0, then e turns into 1, and v naught times 1 is just v naught, so that's where my initial point is. And then if you think about the function of e to the negative power, it is going to decrease at a high rate and then flatten out and get closer and closer to 0. And if you don't have that memorized, you can always graph it on your graphing calculator and get that value. Let's go to part C. So I'm going to erase all of this work here. I do want to keep this function. So I'm going to move that up. And then let's do E. So from E, we have this velocity function there, and I want a function of displacement, which is dx, which is x, so I can plug dx dt for velocity equals v naught e to the negative kt over m. So we're going to do the same thing. This has a t right here, so I'm going to bring the dt over, and I get dx is equal to v naught e to the negative kt over m dt. And then I take the integration of both sides. I'm going to leave the v naught out. X starts at 0 and goes to some function, some displacement x. E starts at 0 and goes to some displacement or some time t. Integral dx is just x, and if I go from x minus 0, it just leaves it as x, so I'm not going to do that work. And then v naught, when I integrate e to the negative power, I have to take e and the same power, but I now have to divide by negative k over m, which is just multiplying by the reciprocal. So instead of dividing negative km, I'm going to go in and multiply by negative mk. So negative m over k like this, and this also goes from t to 0. Now here, I'm just going to rewrite the expression. I also have, I'm going to pull out my other constants now. So the negative m and k will go with the v naught. And I'm going to take my e to the negative kt over m, if I just substitute the t, and then e, and subtract that from e to the negative 0 power. This just turns into 1. And so I am going to get x is equal to negative v naught m over k times e to the negative kt over m minus 1. This isn't exactly what you see in your physics helper, but you can manipulate some negatives and get it to the same equation. From there, we want to graph this. And if we have time equals 0 here, e is equal to 1, and 1 minus 1 is 0. So 0 times the constant that I have here is just 0, so I know it's going to start here at 0. And then from there, I've got a, actually, I think it is easier to rewrite this. If I take this negative and distribute it, I get x is equal to v naught m over k, and then I get 1 minus e to the negative kt over m. And then from there, I can figure out as t goes to infinity, and we can see it in this equation right here, it approaches 0. So this ends up turning into 0, and it's just v naught m over k times 1. And so as the function goes to infinity, it's going to reach a value here of v naught m over k. And that actually answers our distance traveled by the block from t0 to t infinity. As we stated, if we plug in 0 for time, x is equal to 0 because 1 minus 1 equals 0. And as t goes to infinity, we have this function for e of negative t here. Even though this is the velocity function, we can see that that e to the negative goes down to 0. And so if I plugged in 0 for this equation right here, then I would get v naught m over k. Hopefully that was helpful. Let me know if you have any questions, and good luck on the test.